So welcome again to this another session of integration of polynomials. So today we are shifting to the semifinals of the MIT 2023 Integration B. And in this session, we're going to look at three questions that stood out that pertain to the polynomials. The first question was the integration of 9 times x to the power 9 minus x to the power 90 plus 9 times x to the power 99 minus x to the power 900 plus 9 times x to the power 909 minus x to the power 990 plus 9 times x to the power 999 minus x to the power 9000, and so on as the series continues to infinity. And this was from 0 to 1. The next question was the integration of into bracket square root of x plus 1 minus square root of x to the power pi. And the last question was the integration of x squared minus 2, all that squared minus 2, all that squared minus 2, all of that squared minus 2 from negative 2 to positive 2. So before we proceed, I would like to really encourage those of you who are here for the first time to subscribe to our channel. For those of you who have not subscribed, please subscribe. This will allow us to provide you notifications every time we come up with solutions, but also it helps us give us the profile that we need. So on to the first question. This question was question number 2 in the first semifinals. And we want to use two lemmas to solve this question. The first lemma pertains to 1 being equal to 0.999999 all the way to infinity. And the way we can express this in a fraction format, this is 1 is equal to 9 over 10 plus 9 over 100 plus 9 over 1000, 9 over 10,000, and so on to infinity. So this can be expressed in this beautiful summation of 9 over 10 to the power k, from k is equals to 1 to infinity. And then the other thing is we can also express this in an integral format because this 10k could be taken up as a power of x, and then we keep the constant 9 so that we have 9 times x to the power 10 to the power k minus 1 integrated from 0 to 1. So this can also be, you could blow it out so that we have 9 times x to the power 9 plus 9 times x to the power 99 plus 9 times x to the power 999 plus 9 times x to the power 9999, and so on, integrated from 0 to 1. So this is equal to 1. And so looking at our integral, there are some components that would be equal to the components we see here in this first lemma. So the first one, the third one, and the second last one here. Now the question is, what are these other remaining terms equal to? For example, negative x to the power 90 minus x to the power 900 plus 9x to the power 909, and so on. And this we'll try to decipher in our next lemma. So the second lemma here, when you have x to the power s integrated from 0 to 1, this is the same as x to the power s plus 1 over s plus 1 from 0 to 1. And so that is equals to 1 over s plus 1. The next thing is, since this answer here is the same as 1 over s plus 1 times 1, and we know that 1 is equals to the summation of 9 over 10 to the power k, from k equals to 1 to infinity, we can pull s plus 1 into the summation sign. And so expressing this into an integral format again, we're able to pull s plus 1 up. So it's x um, to the power s plus 1 times 10 to the power k minus 1. And then we keep the constant of 9 there. So that when we have such an integral, when we plug in, for example, s is equals to 90, when you integrate that, it's the same as the integral of 9 times x to the power 909 plus 9 times x to the power 9099 plus 9 times x to the power 90,999. When you plug s into s 900, we get this integral of 9 times x to the power 9009 plus 9 times x to the power 90,099 and so on. And so when you plug 990 in place of x of s, we get these multiple combinations of 9x to the power 909 and 9009 and so on. So what this means is in our final integral here, since we already have the 9999 with no zeros as powers, when we look at the negative x to the power 90, for example, this has its counterpart here. It's supposed to be equal to this integral. And we see that in our series, we have the first component there. And for certain, the next component that was going to follow here is the second component there. So since this is negative and this is positive in this summation, a series summation, it means that this and that would cancel obviously with the succeeding terms. And so would be negative x to the power 900. It would cancel out with the succeeding 9999 components. And so would the x to the power 900 and x to the power 990. So all we are left with is that our integral, which is complicated, is the same as the integral of 9 times x to the power 9 plus 9 times x to the power 999 plus 9 times x to the power 99 and then 999, and that's the same as 1. So the answer here really is 1. This is the final answer. It's simple, but it required a keen understanding of what was taking place. The next problem, which was the integral of the square root of x plus 1 minus square root of x to the power pi, which was the semifinal number 2 first question. Here what we could do is, first of all, we would have to substitute for whatever is in the bracket. So we say let u equals to square root of x plus 1 minus x, so that du dx is equals to a half of 1 over square root of x plus 1 minus half of 1 over square root of x. And so du dx is equals to, when you combine the two fractions, negative a half of square root of x plus 1 minus square root of x over square root of x plus 1 times square root of x. And when we take the fraction to the left-hand side, it means a negative 2 square root of x plus 1 times square root of x over square root of x plus 1 minus square root of x du is equals to dx. So we can express this new denominator in form of u, but the numerator is a little bit complex. So the next portion is how can we express this part here in place of u, in form of u. So since we know u to be equal to the square root of x plus 1 minus square root of x, then if we take square root of x onto the left hand side, and then we square both the left and right hand side. So we get u squared plus 2u square root of x plus x is equals to x plus 1. But then the x's here cancel, and so you're left with u squared plus 2u square root of x is equals to 1. And then we can now take 1 to the left hand side, and then take the 2u square root of x to the right hand side. So u squared minus 1 is equals to negative 2u square root of x. And therefore square root of x is equals to negative u squared minus 1 over 2u. Okay, so we have one part of that product. The next part is we could still take the square root of u x plus 1 onto the left hand side, as shown here, and then on the right hand side we're left with negative square root of x. When you square both right hand and left hand sides, we're left with u squared minus 2u square root of x plus 1 is plus x plus 1 is equals to x. So the x's here cancel one another, and so you're left with u squared minus 2u square root of x plus 1 is equals to 0, plus 1 is equals to 0. So we keep the u squared plus 1 on the left hand side and transfer the 2u square root of x plus 1 to the right hand side. And so when we make square root of x plus 1 the subject, we get that square root of x plus 1 is equals to u squared plus 1 over 2u, right? And so the derivative that we had seen there of the product of 2 plus the product of 2 square root of x plus 1 square root of x over u du is equals to dx with a negative sign there is the same as negative 2 over u, so the 2 and the u out, negative u squared minus 1 over 2u times u squared plus 1 over 2u du is equals to dx. So the negatives cancel out, so it becomes positive now, and then we have these 2 and one of the 2's going. So we have u squared minus 1 times u squared plus 1 over 2u to the power 3, the 3 u's here. And so the numerator there is the same as u to the power 4 minus 1 over 2u cubed du is equal to dx. So substituting into the integral in place of the square root of x plus 1 minus square root of x, we put in u. We have u to the power pi, and then keeping whatever was substituted for dx, we have u to the power 4 minus 1 over 2u cubed. So multiplying the u to the power 4 to the power pi across, u to the power pi times u to the power 4 is equals to u to the power pi plus 4 divided by 3, we get u to the power pi plus 1. The constant obviously can be taken out, and then u to the power pi minus times negative 1 is the same as negative u to the power pi, and then divided by u to the power 3, we get pi minus 3. So when you integrate everything, you get a half into bracket 1 over pi plus 2 to the, times u to the power pi plus 2 minus 1 over pi minus 2 times u to the power pi minus 2 plus c, the constant. Since we know u to be square root of x plus 1 minus square root of x, the integral of square root of x plus 1 minus square root of x to the power pi is the same as half of 1 over pi plus 2 times the square root of x plus 1 minus square root of x to the power pi plus 2 minus 1 over pi minus 2 times the square root of x plus 1 minus square root of x to the power pi minus 2 plus a constant c. And this is the answer that was being asked for. Lastly, is this question that to me I think was really demanding one to be able to expand out this integrand. So eventually that when expanded out is the same as the integral of x to the power 16 minus 16 times x to the power 14 plus 104 x to the power 12 minus 352 times x to the power 10 plus 600 60 times x to the power 8 minus 672 times x to the power 6 plus 336 times x to the power 4 minus 64 times x squared plus 2. So when you integrate that, you get this very long expression. And then you plug in the limit, minus 2, and on the lower side and 2 on the upper side, you get negative 8 over 255. So indeed, thank you very much for walking along with us. For those of you who are not subscribed, again, I do encourage you to subscribe to our channel. But again, it was fun solving these questions, and I hope you have a fun rest of your day. Thank you.